Since its launch in late 2021, the James Webb Space Telescope has shattered every expectation we had about the universe, revealing phenomena so extraordinary that leading scientists are calling it a crisis in physics, from galaxies that shouldn't exist to hints of worlds with conditions ripe for life. JWST is challenging everything we thought we knew about the cosmos. What if the origin of the universe isn't what we've been taught? What if the early universe was stranger, more complex, and far more mysterious than we ever imagined? Stay with us, because what you're about to see will change the way you look at the night sky forever. It all began with whispers from the edge of the observable universe. In July 2023, astrophysicists analyzing deep field data from JWST identified three peculiar galaxies that defied every expectation. Their light didn't match the patterns of ordinary star formation. Instead, it hinted at something entirely new: dark stars. These theoretical objects, fueled not by nuclear fusion, but by dark matter, could have grown to unimaginable sizes in the early universe. If real, dark stars might explain the abundance of supermassive black holes scattered across the cosmos, offering a missing piece to a puzzle scientists have struggled with for decades. Dark matter itself makes up 85% of the universe, yet remains one of its greatest mysteries. The discovery of these potential dark stars isn't just intriguing, it threatens to rewrite the story of how stars and galaxies formed, and JWST was only just beginning to unveil the secrets hidden in the cosmic darkness. After uncovering hints of dark stars, JWST shifted its focus to a distant exoplanet known as GJ1214b, a super-Earth orbiting a red dwarf roughly 40 light-years away. Previously dismissed as too hot and obscured by thick clouds to study, JWST's infrared instruments penetrated the dense atmosphere, revealing something extraordinary. Enormous clouds of water vapor swirled across the planet, and some regions appeared surprisingly temperate, hinting at the potential for habitability. Even more astonishing was the detection of methane, a compound often associated with biological activity. This raised a tantalizing possibility. GJ1214b could be a water world entirely covered by oceans, with conditions that might support life. These findings suggested that planets once considered inhospitable could, in fact, harbor the building blocks for life, bringing humanity closer than ever to answering the age-old question: are we alone in the universe? JWST's observations were rewriting our expectations of planetary environments, showing that the cosmos might be far more capable of nurturing life than previously imagined. While exploring the far reaches of the cosmos, JWST made an unexpected and startling discovery: signals resembling smoke from 12 billion years ago. Observing a distant galaxy at the edge of the observable universe, the telescope detected polycyclic aromatic hydrocarbons, organic molecules commonly associated with smoke and vital to life on Earth. These molecules had traveled across the cosmos for over 12 billion years to reach us, amplified by the phenomenon of gravitational lensing, which magnified the light from this ancient galaxy. The implications were profound. The fundamental building blocks of life existed long before Earth even formed, suggesting that life might not be a rare accident, but a likely consequence of the universe itself. This revelation challenged conventional notions about the timing and distribution of life-forming elements, hinting that the seeds of biology could be spread throughout the cosmos. JWST was demonstrating that the universe was not only ancient and vast, but also potentially fertile, and that the ingredients for life might be far more common and widespread than previously believed. One of the most staggering revelations from JWST came from its ultra-deep field imaging, which revealed ancient galaxies far older, denser, and more developed than current cosmological models could explain. These galaxies, forming less than 600 million years after the Big Bang, already contained supermassive black holes, some 1,000 times the mass of the one at the center of the Milky Way. According to standard theories, the early universe simply did not have enough time or material to produce such mature structures. Yet there they were, challenging our understanding of cosmic evolution and forcing astronomers to confront the possibility that the timeline of galaxy formation might be drastically different from what had long been assumed. This extraordinary density and early development suggest that the universe may have accelerated its evolution in ways that our models cannot yet account for, and that the processes leading to the formation of stars and black holes may have been far more efficient than previously imagined. Joel Leyer, an astronomer at Penn State, described these findings as the most puzzling and intriguing collection of objects he had ever encountered, underscoring the profound implications of JWST's discoveries for our comprehension of the universe's earliest epochs. Among the many astonishing images captured by JWST, one in particular sent shockwaves through the scientific community. A nearly perfect spiral galaxy, symmetrical in shape and color, appearing almost too flawless to be natural. What made this discovery even more perplexing was the unexpected duplication of its spectral signature. JWST recorded what seemed like a mirror version of the same galaxy, slightly displaced in both time and space, yet exhibiting synchronized energy fluctuations, matching redshifts, and identical movement in its star clusters. While gravitational lensing can sometimes create distortions or multiple images of distant objects, this phenomenon went far beyond known effects. Some theorists are now contemplating radical explanations, including the possibility that we are glimpsing an artifact of a multiverse overlapping realities subtly imprinted on the cosmic fabric. If so, JWST may not only be a window into the universe's distant past, but also a tool that hints at parallel versions of reality, raising profound questions about the nature of space, time, and existence itself. JWST's sensors, though primarily designed to capture infrared light, have also revealed an astonishing new dimension: the subtle vibrations of dying stars. In early 2024, while observing a star in the Carina Nebula nearing the end of its life, the telescope detected a rhythmic low-frequency pattern unlike anything seen before. When converted into audible sound waves, the star's collapse emitted a repeating pulse, eerily precise, resembling a heartbeat or a coded signal. Typically, stellar deaths are chaotic, producing irregular bursts of light and energy, yet this star seemed to follow an ordered rhythm, as if communicating a message from its final moments. Astrophysicists are divided. Some believe it is a natural phenomenon of stellar physics we have yet to understand, while others suggest it could hint at something far more mysterious. Whether it is a cosmic signal or a natural quirk of physics, the discovery challenges our assumptions about stellar evolution and introduces the unsettling possibility that the universe itself might be sending messages through the death of stars. As James Webb continued mapping the cosmos, its data revealed something even more baffling: a vast region of space entirely devoid of galaxies, stars, or dust, a cosmic void. At first glance, it appeared to be empty, but when analyzed using an AI trained to detect patterns in Webb's data, the void displayed a rotational spiral, not of matter, but of gravitational distortion. This strange phenomenon had briefly appeared in Hubble's observations, but was dismissed as noise. Now confirmed, it pulses and moves, bending space around it like a lens, defying all known physics. Astronomers cannot classify it, labeling it only as an unknown entity. The discovery raises unsettling questions. Is this a naturally occurring structure, a gravitational anomaly, or something far stranger entirely? Whatever it is, it challenges our understanding of the large-scale structure of the universe, revealing that even the empty regions of space are far from simple or silent. The James Webb Space Telescope's final revelation may be its most mind-bending: a temporal distortion in a distant sector near the constellation Fornax. Here, galaxies appear to reverse age, with their light signatures growing younger, the farther they are from us. Under the standard model of cosmology, this is impossible. Redshift should increase with distance, reflecting older light. Scientists are grappling with the implications, suggesting either a flaw in our understanding of space-time or a cosmic anomaly akin to a scratch on a record that replays notes out of order. Some theorists call it a time fold, while others speculate it could hint at the universe behaving like a simulation. Either way, this discovery challenges the very notion of time as linear and reliable, forcing astrophysicists to confront a reality where the past and future may not follow the rules we thought were absolute. James Webb has shown that even the flow of time itself can be mysterious, bending and unpredictable, leaving the scientific community in awe and uncertainty. So here we are, standing at the edge of understanding, peering into a cosmos that no longer follows the rules we once trusted. The James Webb Space Telescope was built to confirm theories and illuminate the unknown, yet it has shattered the script of modern science. From dark stars born in the shadows of creation to galaxies that matured far too quickly, from echoes of potential parallel realities to the haunting heartbeat of dying suns, Webb isn't just revealing the universe, it's redefining it. Artificial intelligence now flags anomalies, patterns that defy classification, and gravitational distortions that warp the space between galaxies. What Webb has uncovered goes beyond what we expected to see, challenging our notions of beginnings, time, and the very laws of physics. What we once considered immutable may only be guidelines, and the universe might be far stranger and more complex than we ever imagined. If this is only the beginning of Webb's journey into the unknown, then the discoveries to come could fundamentally change our understanding of reality itself. The universe is not silent, simple, or solved, and the telescope has only just started to reveal its deepest, most mysterious secrets.